We live in a world that is meticulously tracked. Every time a commercial flight takes off, it enters a highly synchronized global grid, passing continuous streams of data between the aircraft, satellites, and ground control. On the night of March 8, 2014, Malaysia Airlines Flight 370 entered that grid. It was a routine red-eye flight, operating a Boeing 777-200ER, scheduled to fly from Kuala Lumpur to Beijing. On board were 239 people, 12 crew members, and 227 passengers from around the world, settling in for a 6-hour journey. Less than 40 minutes into the flight, as the plane cruised over the Gulf of Thailand near a navigational waypoint known as Igari, the pilot said goodnight to Malaysian air traffic control. Then, all communications abruptly stopped. The aircraft disappeared from civilian radar screens. There was no distress call, no automated warning of mechanical failure, and no indication of bad weather. Pacing slows down slightly. How a 300,000-pound commercial airliner manages to completely untether itself from the modern surveillance network remains one of the greatest mysteries in the history of aviation. To understand how a plane drops off the map, we have to look at how air traffic control tracks them in the first place. Civilian systems rely on secondary surveillance radar. This requires a device on the aircraft, a transponder, to actively broadcast the plane's identity, altitude, and speed back to the ground. At exactly 1:21 a.m., MH370's transponder stopped transmitting. Without that cooperating signal, civilian radar was effectively blinded. But the military relies on primary radar. Instead of waiting for a broadcast from the plane, primary radar forcefully bounces radio waves off solid objects in the sky to see where they are, regardless of whether their tracking equipment is turned on. When investigators reviewed the Malaysian military's primary radar data, they found the aircraft. It abandoned its route to Beijing, making a sharp turn back toward the Malay Peninsula. The radar tracked the Boeing 777 flying northwest up the Strait of Malacca, continuing until 2:22 a.m., when it finally flew past the physical range of the military radar network. A deactivated transponder, paired with a highly specific navigational path away from land, points to deliberate human evasion. Someone was actively flying the plane into the dark. Even with its primary communications dark, the aircraft had one final layer of tracking left on board, the Automated Satellite Data Unit, or SDU. Investigators found a strange anomaly in the data logs. Power to this unit was somehow severed shortly after takeoff, but at 2:25 a.m., 3 minutes after the plane vanished from military radar, the SDU mysteriously powered back up, logging on to the Inmarsat satellite network. Looking at these complex satellite coverage maps and data logs, investigators isolated automated electronic check-ins between the plane and an Inmarsat satellite hovering over the Indian Ocean. By analyzing the timing and frequency of these check-ins, known as BTO and BFO handshakes, they mapped the plane's unseen movements for another 6 hours. The investigation also extended to the crew's backgrounds. The FBI analyzed a flight simulator in the captain's home and recovered a deleted course that closely resembled this southern route into the open ocean. The mathematics of these invisible ghost pings confirmed a grim reality. The plane was flown steadily south, deep into one of the most remote oceanic regions on the planet, flying until its fuel tanks finally ran dry. Based on the final satellite handshake, investigators calculated a boundary curve known as the seventh arc. Somewhere along this line, having donned through 41,500 kilograms of jet fuel, MH370 hit the water. Malaysia, Australia, and China launched a massive joint operation, but after a 2-year, $130 million underwater hunt, spanning tens of thousands of square miles of hostile seabed, they found no trace of the main fuselage. The ocean eventually offered its own receipts. In July 2015, a large piece of a Boeing 777 wing, called a flaperon, washed ashore on Reunion Island, over 2,000 miles west of the underwater search zone. Serial numbers confirmed it belonged to the missing plane. Today, scientists are studying the growth patterns and chemistry of the older barnacles attached to this debris, hoping to trace the specific oceanic temperatures and chemical records back to the exact site where the aircraft first went down. This ongoing analysis has revived the physical hunt. Malaysia recently agreed to a renewed search spanning 2024 to 2027 with the marine robotics company Ocean Infinity, operating on a strict no-find, no-fee basis. While the search resumes, the families of the 239 passengers and crew remain in a state of suspended grief. More than a decade later, they are still waiting for a physical resting place for their loved ones and definitive answers about what happened. The disappearance exposed critical vulnerabilities in global aviation. In response, the industry implemented new safety regulations, increasing the battery life of underwater locator beacons and requiring stricter, continuous position reporting over open oceans. The goal is to ensure that a passenger jet can never simply vanish again.